This video is going to focus on a second way of solving equations, a way that I can look for if I can't write both sides as a common base, and that is to use logarithms to solve an exponential equation. Before we just dive into the examples, let's get a list of steps that we can follow to actually solve this type of equation. In this case, I have an exponential equation that I cannot write as a common base on both sides of the equal sign. So my goal here is, number one, I need to isolate that exponential expression. Once I get it isolated, I pay attention to what my base is. If it's a base 10, I use a common log. But if it's any other base, I tend to use the natural log. So take the common log of both sides for base 10, the natural log of both sides for anything else. Then simplify using our properties. You took the natural log of base b to the x, bring that x down, use that power rule, okay? If you took the natural log of e to the x, that's just x. If you took the common log of 10 to the x, again, that's just x. So whichever one you do, that's where you're going to start, and you're going to solve for the variable x now. Because I know that that algorithm can be quite confusing, let's take a look at a couple of examples. First, I have 5 to the x equals 134. Because I know 5 won't go into 134, I don't stand a chance at getting a common base on both sides. Because it is not base 10, I want to use the natural log just because I like it better. Natural log of 5 to the x equals the natural log of 134. Now, this is not base e on either side, so I am going to bring the x down and say x times the natural log of 5 equals the natural log of 134. Since they multiplied my x by the natural log of 5, I'm going to divide both sides by the natural log of 5. And that's when I'm going to reach for my calculator, because now I've got x equals. So I'm going to type natural log of 134. Well, I'm going to try to. Natural log of 134 divided by natural log of 5. And I get 3.04 to the nearest hundredth. Okay? So, again, this is why I want to use the base 10, the common log, or the base e natural log, is because I have those buttons, that capability on my calculator. Now, in the case of a base 10, on my next example, I want to take, by the way, this is not a power of 10 because of the 8, but I want to take the common log of both sides. Log base 10. And I'm going to actually do this one on the calculator, and then I'm going to tell you a little secret. Okay, log base 10 of 10 to the x is just x. So I can type in log of 8,000, and I'm actually going to do that so that I can show you this is 3.90. Okay, now I could have broken this down, but since I had a calculator, I didn't want to. I could have broken this down into the log of 8 plus, because when you multiply, you add the logs, plus the log, that's 8 times 1,000. This is 10 to the third. So this is log of 8 plus 3. If I had to do this without a calculator, that would have been my final answer. But given the calculator, there's no sense in doing all this breaking down when you can just type it in. And one last example that's just a little bit more involved. Again, base 3, base 7, there's no way I'm going to get a common base out of those guys. So I'm going to take the natural log of both sides. So the natural log of the left-hand side equals natural log of the right-hand side. Now, I have an expression behind a logarithm that is raised to a power. So I'm going to bring the power down, and I'm going to put him in parentheses so that I don't mistakenly think it's just -1 times the natural log. So I'm going to put them in parentheses and bring them down and multiply them. Okay. Now, here comes the question, how do I isolate the x? I want only the x's on one side and everything else on the other. So here's what I'm going to do. I'm going to distribute 2x times the natural log of 3 minus 1 times the natural log of 3 equals x times the natural log of 7 plus 1 natural log of 7. Now, I'm going to move the x natural log of 7 to that side and the minus natural log of 3 to the other. So, since it's, let me get it written out. Since it's x natural log of 7, positive on the right, I'm going to make it minus on the left, and I'm just going to leave my x off, I guess. Natural log of 7 equals natural log of 7. Since it's minus, I'm going to say plus to move it to the other side, the natural log of 3. Now here, I'm going to factor out a common factor of x. That leaves me with 2 natural logs of 3 minus natural log of 7. And then I'm just going to copy the other side down because I'm not doing anything with him right now. Now I've got the x, but since they multiplied by that stuff in parentheses, I'm going to divide by that stuff in parentheses. That makes a 1 over there, kind of cancels out, and that leaves me x equals. Now let me explain the difference in answers here. If you're operating in a class like my students are, that is not allowed to use a nice calculator, we're stuck with 4 functions, then this is my final answer because we cannot do all these evaluations without a nicer calculator. However, if you have a scientific or graphing calculator, be sure that you put your numerator in parentheses and your denominator in parentheses to make sure that, let me see if I can get this done, to make sure that that the calculator does not misunderstand your grouping there, because your numerator is grouped together. I'm doing too much talking, I can't type. Your numerator is grouped together by the division sign there, as is your denominator. So be sure you enclose them in parentheses if you're using the graphing calculator. ln of 3, natural log of 3, minus natural log of 7. And I get 12.11. Okay. Now again, it's all in which calculator you're using. If you're not allowed a scientific or graphing calculator, then you'll have to leave it as the natural log of 7 plus the natural log of 3 over 2 natural log of 3 minus natural log of 7. If, however, you can use the calculator, again, be sure you put the numerator and the denominator inside parentheses to prevent your calculator thinking you just had natural log of 3 over 2 natural log of 3. Okay? All right, best of luck to you.